So we gotta turn to the previous page. I'm recording here. Sketch a set of functions whose product builds a quartic function. So we need something to the fourth power there. Okay. So let's see what we got. Ooh, 4 imaginary zeros. 4 imaginary zeros. Remember, the word imaginary basically says it's not going to touch the x-axis. It's not going to touch it, right? So you can form, well, how do I get double? How do I get 2 imaginary zeros? That's a quadratic. So if I did something like this, class, is that touching? No. So right there would be 2 imaginary zeros. And let's just say you want to build another one. Let's say up here. What's the big idea here? I have a quadratic. Can't spell. You might make the same mistake I just did. Quadratic actually means not 4 but 2. And this is 2. So a quadratic times a quadratic equals a quartic. And that means x to the second times x to the second equals x to the fourth. Again, maybe extra credit for tomorrow's quiz or bonus. Can you write an equation for the pink and the green? Well, you have a quadratic, so x to the second, and you'll notice that it's just shifted up 2 units. So that would just be plus 2. And this one would be x squared what? Plus 8. Because if I multiply all those out, I'll get something to the fourth power. But the big idea is you recognize that they're not touching the x-axis. Remember, it touches the x-axis. Those are called real zeros. And we have imaginary zeros here. So that kind of reviews the fundamental theorem of algebra. In this case, it would be 2 imaginaries plus 0 reals, and then I have 2 imaginaries here. So 2 plus 2 equals 4. 4 plus 0 equals the 4 that we need.